Welcome. I'm going to derive a formula for the volume of a hemisphere. My method will be to approximate the volume by filling it with a stack of disks and then letting the number of disks increase on the assumption that as the number of disks increase, the approximation to the volume made by summing the volumes of these disks becomes more accurate. So I will get an expression v sub n, hopefully that will depend strictly on the radius and the number of disks that I use to fill the hemisphere. In order to calculate the volume of these disks, I will use the normal formula for the volume of a disk. Notice that each disk will have a different radius, r sub I, and so each volume, v sub I, will be different. The thickness of each disk will depend only on r and n, simply the radius divided by the number of disks will provide the thickness of the disk. In order to calculate the radius of the ith disk, it will be convenient to have the height of the top of the ith disk, which would be I times the thickness of the disk. I'll use Pythagorean theorem, considering r as a hypotenuse and y sub I as one leg of a triangle and r sub I as the second leg of the triangle. Substituting in my expression for y sub I now have an expression for the radius of the ith disk in I, R, and N. I can now write an expression for the volume of the ith disk in terms of R, I, and N. Now to write my approximation for the volume of the sphere using n disks, I will sum these n disks volumes. Some algebra will make it clear that I will use the sum of the first n squares, and I will get an expression which I can consider as n becomes very large. It should be apparent by looking at this expression that the second and third terms of the factor at right will become very small as n becomes very large. As n approach infinity, they will approach zero, and my approximation for the volume of the hemisphere will be the familiar 2/3 pi r cubed. Thank you.